In this video, we're going to solve absolute inequality example 9G in your lecture note. Solve the absolute inequality x squared minus 5x plus 3 less than equals to 3. Since the absolute inequality have one modulus, we have to use basic definitions. Refer Golau method. As you can see here, this question is less than equals to 3. It means that we have to use law. For these equations, absolute value of x squared minus 5x plus 3 can be defined as x squared minus 5x plus 3 less than equals to 3 and x squared minus 5x plus 3 greater than equals to minus 3. Let's solve this quadratic inequality. The first one is x squared minus 5x plus 3 less than equals to 3 will be simplified as x squared minus 5x less than equals to 0. Then, factorize this quadratic will give us x times x minus 5 less than equals to 0. Let x times x minus 5 equals to 0 to get the root of x, which we have x equals to 0 and x equals to 5. In order to find the range values of x that satisfy this quadratic inequality, use table of sign. Negative infinity to 0, 0 to 5, and 5 to infinity. The first row is the test value. Choose any values that lies between minus infinity to 0, 0 to 5, and 5 to infinity, which I assume minus 1, 2, and 6 respectively. Then, test this value into x and x minus 5. Which will give us negative, positive, positive, negative, negative, positive. And the final answer, it will be positive, negative, positive. We take negative, which is 0 to 5, because the quadratic inequality here is less than equals to 0. Now, moving on to the next quadratic inequalities, which is x squared minus 5x plus 3 greater than equals to minus 3. Solve this quadratic inequality, and by using factorization method, we get the factor x minus 3 times x minus 2. By let these two factor equals to 0, we get the real root x equals to 3 and x equals to 2. Apply the same method, which is use table of sign, and put any value that lies between minus infinity to 2, 2 to 3, and 3 to infinity, which I assume it will be 1, 2.5, or 4 respectively. Then, test this value. And we can say that the range value of x that satisfied this quadratic inequality would be minus infinity to 2 or 3 to infinity. Now, to find the real answer, we have to find the intersection of these two set values of x. In order to do that, we have to use real number line. So, by using real number line, the intersections will be 0, 2, or 3, 5. Therefore, the final answer would be x is between 0 and 2 inclusively, or x is between 3 and 5 inclusively.